Alright guys, so today we're going to look at 2-2 and 2-3. The top line will say just 2-2, but when I combine them together, the master slide doesn't change, so it is just 2-2 and 2-3 today. Again, I'm taking care of my son today, so just to be forewarned, he may start crying in the middle of it. I'll try to pause the video and settle him down before it gets too crazy, but he's been kind of fussy today. So today, our warm-up number one was to define a vocab word on a note card that you picked up when you walked in the room. So that's already been done, and so we're going to look at number two first. And number two says to determine whether the conjecture is true or false. We are given a triangle ABC. If the measure of angle A is 60, the measure of angle B is 60, and the measure of angle C is 60, the conjecture is that triangle ABC is an equilateral triangle. And of course, that is true because an equilateral triangle has to have three equal angles and three equal sides. So this is true. All angles are equal in an equilateral triangle. Okay. So moving on today, again, we're going to look at logic, but we have some vocab words we're going to look at today. A big list out of our 40 total vocab words. Most of them are there, and actually there should be one more. Contrapositive is missing from this list. I don't know why that is. I didn't cut it out, but it somehow didn't make it on here. But it is also another vocab word that we're going to look at today. So first thing here, we got three of our vocab words. You don't really need to worry about the definitions because, again, we've already looked at the definitions of all three of these words. But the key here is the symbols that we'll use to represent those things. So a negation is our first vocab word. And we use that squiggly line in front of the P to represent a negation, which means not. So you're going to read that as not P. And then for conjunctions are and statements. So basically you are kind of like you're starting to write a capital A, but you just don't draw the line connecting the two parts of the hill. So that caret going up represents and, so that is read P and Q. And then the opposite for a that says disconjunction, that should be a disjunction. This is the only time disconjunction shows up on all of the things in the book and on the notes. I don't know why it's a disconjunction, but basically it's an or statement. So instead of the caret going up, it's caret going down, and it's P or Q. Okay, so now we're going to use that. We have three statements here. We're going to decide if they are true or false, and then we are going to combine them with a conjunction and decide if the conjunction is true or false. So first off, we need to go through each of the three statements and decide if they are true or false. So 1 foot is 14 inches, that is definitely false. 1 foot is 12 inches. September has 30 days. If you don't know, 30 days have September, April, June, and November. So the very first one is September in that little phrase, and so that one is true. September does have 30 days. And then the last one are a plane is defined as 3 non-collinear points. That's something we've been looking at in class. That is true as well. So now we have each individual statement being true or false. So now it wants us to write a compound statement. I'm going to have to write the whole statement out, but basically you would combine the two into one full sentence with an and in between. So P and Q will be 1 foot is 14 inches and September has 30 days. So, again, we have our symbols, right? P and Q. And basically we can replace P and Q with their truth value. So, P is false, right? We said that already. And Q is true. So, the way I like to look at these is with cake and ice cream, or cake or ice cream when you're looking at disjunctions. If you say to somebody that you want cake and ice cream, you want both of those things. So if you don't get one of them, you're not getting what you actually asked for, right? So here, You say you want cake and ice cream, but you don't get cake, you just get ice cream. So you're not happy. So that means this whole statement is false. So with and statements, if you get one false statement out of the two, then the whole thing is false. Part B wants us to do not P, so we're going to change the value of P from false to true. So not P would be 1 foot is not 14 inches, and a plane is defined by 3 non-collinear points. So not P and R. Again, P was false, so not P is true, and R, we said earlier, was true. So true and true. Everything's true. The whole thing is true. Okay, so we're going to look at 3 more of these. 3 more statements. Got to again come up with what their truth value is individually first. So, June is the 6th month of the year. That's true. A square has 5 sides. That is false. A square has 4. 4 equal sides specifically. And then, of course, R, a turtle is a bird. Definitely not true. That one's false. Okay, so now compound statements. These are both and statements again. So P and R, we're going to write out in symbol form. We already said that P was true and R was false, so true and false. Now you're not getting your ice cream, but you got your cake. And so again, you're still not happy. You wanted both. Our next one here, not Q. So Q was false, not Q would be true. So not Q and not R. So again, Q is true, or Q is false, sorry. Not Q would be true. R was false, not R would be true. So true and true again, everything's true. So the whole thing is true. Now the only time you get, if you get both things false, then the whole thing is false as well. So that also works. Okay, so now we're going to look at some disjunctions, or disconjunctions if you remember what the note said before. So we have 3 statements again. 6 is an even number. True. A cow has 12 legs. False. A triangle has 3 sides. True. Okay, so compound statements now. These are or statements, so P or R. P or R. We know that P again was true. Or R we said was true. True or true. You're happy everything's true. So if everything's true no matter what, or and, it's true. If everything's false, no matter what, it's going to be false. So not Q or not R. Q is false, so not Q is true. R was true, so not Q is false. Now, here's where it gets different than and statements. Ors are, if you want your cake or ice cream, if you just get cake, then you're happy because you said you want one of the two. You don't say you want both of them. So here, even though we have a false in there, the whole thing is true because one of the parts is true. So we basically said 6 isn't, or no, sorry, a cow does not have 12 legs, and a triangle, or a triangle does not have 3 sides. The first half is true because we have the or in there, the whole thing is true. Last one here, not P or Q. So P was true, not P is false. Or Q, which was the 12 legs for a cow, that's false. False or false, everything's false, so all of it's false. Okay? So now we're looking at truth of tables. So here I went ahead and made the table for us. So the way this works is you want to add a column for each part of what you're looking at. So here we have P, or not P, or Q, right? So we have to have one for P, one for Q, one for not P, and one for the whole thing. So every time you make a truth table, you start out the same way. You do half and half. So half truths. So P can be true or false. And then you do the same thing with Q. So Q is true, false, true, false. So P, the first column, you do half and half. Second column, you alternate. Well, the next problem we're going to look at, we're going to have 3 different letters to start, so it's going to be a little bit different, but kind of the same at the same time. So you'll see. So not P, we're going to change what P is, right? So P was true first, now it's false. P was true, now it's false. P was false, now it's true. P was false, now it's true. So now we're going to do an OR with everything we just did. So true or false or true, really. And again, it's an OR statement, so we have one true, the whole thing's true. So false, false, false. True, true, true. True, false, true. And there's our completed table. Okay, now we have another one. This one's a bit more complicated because we have a lot more going on, right? We have P, we have Q, we have R. We also have a not Q. We have a not Q and R, and then we have the whole thing at the end, okay? So, again, we're going to start out the same way I just said we need to start every table, right? Half and half. So P is going to be true, 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 false, 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 false. Then we're going to alternate. But instead of doing true, false, because we have 3, we're going to do true, true, false, false, true, true, false, false. And now we're going to do the full alternation. True, false, true, false, true, false, true, false. Now we're going to take what we did for Q, true, true, false, false, and flip it. So now it's going to be false, false, true, true. Okay? Now we're going to do an AND statement with the last 2 we just did. Remember, if we have one false, the whole thing's false. So false, false, true, false, 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 true, false. And now we're going to take the one we just did in the very first column and combine those together with an OR. So again, if we have one true, the whole thing's true. So P is true for the first 4. So we don't even care what the other thing says. The first 4 are all true. And then the next ones are false, false, false. Oh, sorry, we're doing an OR here. Sorry, I got a little distracted there. False, false for sure, because they're both false. And then we have a false, true, so that's true. We have a false, false, so false. So there's our completed table. So now if you had given some statements with P, and Q, and R, then you can decide, well, if we have not Q and R or P, these would be the different possible outcomes. Okay? So what truth tables are, they're just showing you all the different outcomes. So we can also show logic things with Venn diagrams. So here we have some dance classes at Monique's dance school for tap, jazz, and ballet. First question, A, wants us to decide how many students are enrolled in tap or ballet. So it's an OR statement, so they can be in either one individually, they can be in both together, but they just can't be in jazz, right? So, or they can't just be in jazz, right? Because really, all the kids in tap alone count, all the kids in ballet alone count, all the kids in both count, because those are including these types of dance, as well as the kids that are in tap and jazz, the kids that are in ballet and jazz, and the kids that are in all 3 different classes. So all 6 of these things need to be added together, and that gets us a total of 121. So A is 121. B, a little bit different. That one's an AND statement, and it has this caveat on the end that is but not, right? So AND means they have to be in both, right? So that means we're looking at this little eye-shaped piece here. But The not tap part means we get to eliminate these 9. So we're just looking at these 25 kids, and that's our answer, 25. Okay? Okay, so now we're getting into 2-3 now. This is getting into conditional statements. A conditional statement is basically an if-then statement, and if-then statement is the form of if P, then Q, where P is a statement and Q is the conclusion, or P is the hypothesis and Q is the conclusion. So here we have the definitions of those things, the hypothesis and conclusion. So if P, then Q, if hypothesis, then conclusion. Okay? So here we have to just identify the parts to these statements. The second one is not in if-then form, but we'll deal with that when we get there. So, if a polygon has 6 sides, then it is a hexagon. This is our hypothesis. And this is our conclusion. It's written in if-then form. It's easy. Okay? Second one is not in if-then form, but there is an if in there, right there. So, she completes the maze in her computer game as our hypothesis. And then she will advance to the next level play is our conclusion. So after she does the first part, or the completing the maze, then she does get to move on. So, okay? So here we have 2 more doing the same thing. Now again, we could come up with if-then, if we wanted to. They're not in if-then form. It says to do that afterwards. We're not going to, though. So measured distance is positive. So if a distance is measured, then it is positive, would be our if-then statement. So there's going to be a little bit of overlap here. If a distance is measured, conclusion, sorry, hypothesis, is positive is our conclusion. If a polygon has 5 sides, hypothesis, then it is a pentagon. Conclusion. Pretty easy in these ones. They are pretty much in that form that we needed, right? Now, we're deciding truth value here. Our first one here, if you subtract a whole number from another whole number, the result is a whole number. Is that valid or invalid? Is there a way to subtract a whole number from another whole number and get a fraction out? No. There's no way to do that. So this is valid. This is true. And the last one, if last month was February, then this month is March. March comes after February, so that is true as well. That's our reasoning behind it. Okay? So now the different related conditionals. So a conditional statement says if P, then Q, right? The converse of that statement flips it. So it takes Q and puts it where P is, P where Q. So if Q, then P. The inverse changes both of them to not statements. So if not P, then not Q. And the contrapositive flips that one and says if not Q, then not P. So here's some examples. If the measure of angle A is 35, then angle A is an acute angle. That's true, right? 35 is an acute angle, so that's good. If angle A is an acute angle, then the measure of angle A is 35. That's not always true, right? You can have a 25-degree angle, and that's still an acute angle, so that's not true. That's false. The inverse says if the measure of angle A is not 35, then angle A is not an acute angle. That's, again, not true because we can have 25 that is an acute angle, and it's not 35. So that's false as well. And that's good because of the next thing we're going to look at. But the last one, if angle A is not an acute angle, then the measure of angle A is not 35. So if it's not acute, it can't be 35 because 35 is acute, so that's true. So the last part of this page here says that logically equivalent statements, a conditional and its contrapositive are logically equivalent, and the converse and the inverse are logically equivalent. So we just went through those 4 examples, and the conditional and the contrapositive were true, which is good because they are logically equivalent like they're supposed to be. And the converse and inverse were false. They are logically equivalent, so they should both be the same truth value. So worked out the right way. So our last example here, there was supposed to be a box here with information. I forgot to put it on here, but that's okay. Basically, bats are mammals that can fly, and that is mammals. They are the only mammals that can fly as well. So that is a blanket true statement. So what we're going to do is come up with our converse, inverse, and contrapositive of a conditional that we're also going to write. We're going to turn this into an if-then statement before we do anything. Then we're going to decide if they are true or false. So the conditional is just taking this statement, making it if-then. So if a mammal is a bat, then it can fly. The inverse is our next statement. Nope, sorry, converse. Converse next, then inverse. Converse just flips this. So if a mammal can fly, then it is a bat. The inverse takes our conditional statement and makes them both nots. So if a mammal, sorry, my handwriting's getting kind of sloppy, is not a bat, then it cannot fly. And then the contrapositive takes the converse and does the same thing that the inverse does to the conditional. So if a mammal cannot fly, then it is not a bat. So now, truth value for each of these. So first off, the conditional we know is true because it says that it is true, or I said it was true earlier, right? If a mammal is a bat, then it can fly. Bats can fly. We know that's true. So remember, logical equivalence says that the conditional and the contrapositive should be the same truth value. So if a mammal cannot fly, then it is not a bat. And again, bats are the only mammals that can fly, so that is true. So our two that are logically equivalent so far are true. And then the converse and inverse should be the same truth value as well. If a mammal can fly, then it is a bat. Again, that's a true statement. Bats are the only mammals that can fly. If a mammal is not a bat, so us, then it cannot fly. Humans cannot fly without the aid of a plane, so that is true. So all these are true. So logical equivalence works, so we're good there. Okay? So we worked in class on this stuff, had some practice problems to do. Hopefully you did those. And then our exit ticket is to take this statement and do the same thing. I'm not going to go over the exit ticket. Again, I want you guys to make sure you know what you're doing on them and get practice. And plus, we already turned in our exit tickets a while ago over this. But basically, if we were to do this exit ticket, the sum of the measures of two complementary angles is 90. Then the conditional would say if two angles are complementary, then their sum is 90. The converse would say if the sum of two angles is 90, then they are complementary. The inverse would say if two angles are not complementary, then their sum is not 90. And the contrapositive would say if two angles do not sum to be 90, then they are not complementary. There we go. Alright? So, moving on to the next video.